This is 2.8, all about graphing linear and absolute value inequalities. Follow along with me on page 17. So we're going to be able to graph linear inequalities and graph absolute value inequalities. So some vocab to get out of the way. A boundary separates the coordinate plane in half when we're graphing inequalities. And because absolute value functions are linear-like, that is why these two topics are paired together. So when we're graphing a linear inequality, we're going to have to make a couple decisions. It's kind of like when we're graphing a regular inequality on a number line, like this. We have to decide, do I want a closed or an open circle? And we have to decide which way is my arrow going to face. So this is building on that idea, except instead of just graphing on one number line, we're graphing on the x and the y axis. Okay, so we have to still use this idea of closed or open circle. And then kind of going along with closed or open circle, we have to decide between a dashed line or a solid line. Okay, and so we'll use a dashed line kind of like when we use an open circle. So we'll use that with less than and greater than symbols, and then we'll use a solid boundary line with filled in circles with greater than or equal to, less than or equal to. So those all kind of go together. If you're thinking interval notation as well, a dashed boundary line would go along with like a parenthesis, and a solid boundary line would go along with an interval bracket, with a bracket. Okay, so to graph these by hand, there are a couple ways to go about it. When you're given something like this, x plus 4y is greater than 2, you're going to think of it like it were an equation, and you're going to graph that line. And then we're going to have to decide which side of the plane to shade. Because if you think about it, there are many, many, many different ordered pairs that would satisfy this. Okay, so in order to account for the fact that there's many ordered pairs that would satisfy this inequality, we're going to have to shade one side of the plane or the other. Okay, so when you're graphing these, there are a couple ways to go about it. If you like working with slope-intercept form, then you can rearrange this inequality kind of like it in slope-intercept form. So if you subtract x from both sides and then divide both sides by 4, you kind of have something in slope-intercept form, and then you're going to graph this like you would a line in slope-intercept form, keeping in mind we want to use open circles and a dashed line. It would work like that. The other approach is to graph using intercepts. So if you want to first find your x-intercept and your y-intercept, for your x-intercept you're going to plug in 0 for y, and for your y-intercept you're going to plug in 0 for x. So for your y-intercept, x plus 4 times 0 is greater than 2. We can kind of think of it like when it's equal to 2 to find this point on that boundary line. And that happens when x equals 2. So our x-intercept is 2, 0. And then our y-intercept, we can see it from when we rearrange to slope-intercept form. Or we could also algebraically plug in 0 for x. So 0 plus 4y is equal to 2. Y would be equal to 1/2. So we see it in two ways there. Okay. And then we can kind of use these methods together to then graph our boundary line, keeping in mind that we're going to use open circles the whole way because points on the line are not going to be included in our solution set. Okay, so my x-intercept is over at 2, 0, so if I graph an open circle there. And then I'm not going to graph this y-intercept because it's a fraction. Instead, I'm going to use this x-intercept and use my slope and generate extra points that way. So from my x-intercept, I'm going to go up 1, left 4, and put another open circle. Up 1, left 4, and put another open circle. Up 1, left 4, and then I can see that I have a nice flat, nearly flat line showing up. Down 1, right 4, down 1, right 4, okay? And then I'm going to very carefully draw a dashed line. Okay, so the line that I'm going to put through this needs to be dashed. So on your paper, you're going to need to make sure to leave some dashes in between. Leave some gaps on your line. It should not be a solid line. Okay, and the next decision we have to make is, do I want to shade this side, the upper half, or the bottom half? So this means, are the ordered pairs up here or down here going to provide the solutions to this inequality? The best way to decide this is just to pick a point on either side, plug it in, and test. Typically, I recommend plugging in the origin, but right now it's kind of hard to see whether the origin falls on the bottom half or the top half of this boundary. So I'm going to plug in the point 1, 2 instead. And if 1, 2 satisfies my original inequality, then I'm going to shade this entire part of the boundary. Okay, so I'm going to plug in 1, 2 to the original. So is 1 plus 4 times 2, is that greater than 2? Is 9 greater than 2? Yes. So because that is true, this ordered pair satisfies that inequality. All the other ordered pairs on this half of the boundary are going to satisfy it as well. So we're actually going to shade, this part of the plane. So forever and ever in both directions, any coordinates that fall above this dashed line would be solutions to the inequality. Take a second, consider what this would look like. So we're going to have a solid boundary line with this one because we have a less than or equal to symbol. This one will be really nice and easy to graph using slope-intercept form, so that's what I'm going to do. My y-intercept is 4, and then I'm going to move down to right 1. These are filled in circles, down to right 1, down to right 1. Keep going forever and ever and ever. And then when you draw your line, it's going to be nice and filled in like this, keeping in mind that you should have arrows on both sides of that line. And then to decide which part of the plane to shade, here it's going to be really nice to plug in the origin because the origin is clearly on the bottom part of the line. So is 0 less than or equal to negative 2 times 0 plus 4? That is our question. Is 0 less than or equal to 4? Yes. So we want to shade the bottom part, just like this. Okay. Another way to kind of test, when your inequality is in slope-intercept form like this, if you have a less than or equal to symbol, you're going to kind of shade below this line. If it's tough for you to tell whether it's above or below, then stick with the plotting technique, picking a point that's clearly on one side, plugging it in and testing it. But if you're able to see that this is kind of like the bottom half of that line, then that's what you would shade. With greater than or equal to, you would shade above. Okay, and so that's one we've solved for y, that we can use that little trick. It's not foolproof, so don't use it all the time, but it works. All right, I'm going to quickly go through these absolute value inequalities. So we're going to graph these as if we were just graphing absolute value equations, graphing those functions, and then we're going to pick a side to shade. Okay, so the absolute value inequality that we have here is just going to be shifted down 4. Then we're going to have closed circles because we have a greater than or equal to symbol. And then we're going to have a nice V shape that emerges. Okay, and then we're going to put our rays going either way. And then are we going to shade inside this V shape or outside this V shape? If you're not sure, plug and check. So plugging and checking, I'm going to check my origin because that's really clearly on one side. So is, using the original equation, is 0 greater than or equal to the absolute value of 0 minus 4? That is our question. So is 0 greater than or equal to the absolute value of 0 is 0, which means we're just left with negative 4. Is 0 greater than or equal to negative 4? Yes. So we're going to shade inside this shape, meaning all the solutions, all these ordered pairs inside forever and ever and ever satisfy our inequality. Last one, same thing, we're going to graph it. Pause the video while you give this one a try. Okay, hopefully you have paused the video, give it a try. Our absolute value graph is going to have a vertex at -1, 3. So it's going to be transformed left and up. And then take a look at these rays. We come and see our V shape. Ask yourself, which side are we going to shade? This is one where y is clearly solved for. So since we have a less than or equal to symbol, we can use that shortcut and say, okay, we're going to shade below. We're going to shade below. If you don't understand that logic of shading above versus below, then it's never going to hurt you to just plug in a point and check. So this origin 0, 0, is 0 less than or equal to the absolute value of 0 plus 1 plus 3? Is 0 less than or equal to the absolute value of 0 plus 1 is going to give us 1. So is 0 less than or equal to 4? Yes. So we want to shade the half of we want to shade the boundary side that includes that origin point. That's all. Take a look at the practice and see how you do.